I'll give you a very brief overview of the IEEE Standards Association and the role that we play right now. For those of you who are familiar with the IEEE is the world's largest professional association advancing technology for humanity. We have over 430,000 members and 45 technical societies in over 190 countries. Many of you are familiar with the conferences that we host each year. We currently have about 1,300 conferences, about over 3.5 million technical documents, and we're cited in over 160 top periodicals. So some very interesting stats there. Now, when we look at the Standards Association, which is a group that resides within the larger IEEE, we do several things here as we build and develop a consensus-based standards development process. So first thing that we're very proud of, we have a very open process where we can have memberships or folks can participate very clearly. It's again a consensus-based platform whereby everyone is based on the WTO and Open Standard principles. We use a number of electronic tools to help facilitate participation, whether you're local or you're traveling or remote-based. And certainly we do our best to engage the global community from around the world. When we look at standardization is borderless. Global standards sustain products and services for implementation and use by customers in a globalized world. We are very active in the MEMS and sensor space. We have a number of initiatives around Internet of Things, smart materials, and obviously sensors. Just wanted to touch upon some of the areas that we focus on or certainly hit in the area of MEMS and sensors. We have a number of standards which are at play in this particular area. I'm not going to read them all here, but certainly when we look at the first one here, Sensor Standards for Performance and Information Capture and Communication. This is the IEEE 2700 and the IEEE 1415. We also have the IoT, or the Internet of Things Framework, which is P2413. All these, you can certainly look on the IEEE Standards Association website for additional information. So with that being said, I certainly don't want to capitalize on this information because our panelists have some great information to share with you. So if I can just give you a very quick read of the bios. First off, we have Karen Lightman. Karen Lightman is the Executive Director of the MEMS and Sensors Industry Group, MSIG. Karen manages the operations of MSIG, spearheads strategic growth, and oversees sales, public relations, marketing, and outreach. Karen is active in the worldwide MEMS conference circuit as a keynote speaker and panelist promoting MSIG's role as the leading trade association advancing MEMS across global markets. Our second speaker will be Peter Lefkin. Peter is the MIPI Alliance Managing Director and is the Senior Staff Executive responsible for all MIPI Alliance activities and operations from strategy development to implementation. As Managing Director, he serves by appointment of the MIPI Alliance Board of Directors. Peter also serves in the role of Corporate Secretary. And then we also have Ken Foust, who's Platform Manager of Intel Corporation. Ken is a sensor technologist and researcher at Intel Corporation, where he's active in sensor and sense-making initiatives across Intel's product portfolio and R&D labs. In this capacity, he also works closely with the sensor industry and its consortiums, driving initiatives in sensors and I/O standardization. With that said, our first speaker I'd like to introduce is Karen Lightman. Karen, I'd like to hand the call over to you, the webinar over to you.
Okay, great. And you're going to push my slides, right?
Absolutely.
Okay, awesome. Thank you, Lloyd, for the great introduction, and I'm really excited to be here with this international group. I know there's folks from around the world joining us today. Again, I'm Karen Lightman, Executive Director of MEMS and Sensors Industry Group. So I'm just going to do a quick little overview. So next slide, kind of talk to you about who we are. We are the organization that represents MEMS and sensors. We're 15 years old. Our focus is on commercialization, the business of MEMS. advancing commercialization across all the markets. So I always think of us as like a horizontal band across lots of verticals, lots of applications, lots of products, and lots of markets. And so you can see here in the hub, we've got device manufacturers all the way through materials and equipment and foundries and designers and end users. It's that whole ecosystem that works together. We are a champion for MEMS and sensors. We also are really big on connecting the community, and we are close to 200 members and partners worldwide. Next slide, please. This is a quick little view, not meant to be an eye chart, but it seems to be, of our members. Next slide is our partners, two of which are here with me today, MIPI Alliance and IEEE Standards Association. I'm a big believer in working and collaborating, and this is a lot of what I want to, kind of drive home today in this presentation, is that it does take a village to do things like standards. Next slide. Also want to share with you some exciting news that starting January 1st, MEMS and Sensors Industry Group, or MSIG, Lloyd, I'm just going to correct you on there. It's the strange acronym of MSIG, will be becoming part of SEMI. SEMI is the world's largest trade association representing the semiconductor industry. And so that'll be something that if you need more information, you can go onto our website or feel free to reach out to me. Next slide, please, is just a quick overview of what SEMI does in terms of their standards programs. They really are focused on the back end. So while what we're going to be talking today is really more external and on the front end and talking about mobile devices and standards and sensor nodes, the work that SEMI does is really more on the manufacturing side of things. And they've been doing standards for, their 40-year history, and they have apparently over 900 SEMI standards already. So next slide is a view of what we do in terms of our work on standards and our working groups. As Lloyd mentioned, the IEEE 2700, we are really proud to have been the instigator for that, and it's the sensor performance parameter definitions. And we are actually in the process of updating the original standard with a version 1.1, and we are also working on 2.0, which is talking about new and emerging sensors like gas sensors and things of that nature. So it's an exciting time to be working in MEMS and sensors, and particularly with standards. And then also we have a working group that we formed with, or a task force we formed with SEMI many years ago, and these are talking about two test specifications, test patterns for DRIE, which is deep reactive ion etching, and specifications for silicon substrates. Next slide. Just want to give a quick overview, and I'm going to let my colleague Ken Foust and Peter Lefkin talk more about this, but we're really proud to be partners with MIPI to help in the creation of the MIPI I3C, which we are strong believers that it's enabling IoT, and they can talk a little bit more about, but this is sort of a teaser to that new two-wire sensor interface that we expect to be released any minute now. So next slide, please. Just a quick plug for our events. We do lots of stuff. We have our standalone events, and then we also do events at big shows like the Consumer Electronics Show, where you can be amongst 150,000 people. I'm putting together with my team here a fantastic full day of conference content. We also have a pavilion at CES. Check out our website for more info. SEMICON China, I'm really excited that we'll be there for the first time with our partner SEMI, doing a full day on IoT and sensors and MEMS there. And we also have our technical congress. We're partnering with Stanford University and their System X, and Sensors Expo and Conference, another important partner of us, will be within June. And then our kind of a signature event is our Executive Congress, which we just had a few weeks ago, and we'll be doing again next November in Napa. Next slide, please. Another plug for a product that we just announced and released. It's a marketplace for MEMS and sensors. It's really the only full directory. It's free for you to access that has a listing of all the MEMS and sensors in that whole ecosystem. It's all in one place. So you should definitely check it out. And like I said, it's free. Next slide, please. I also want to plug that we're a membership organization. I may have mentioned that to be a member, our members pay annual dues. We're big believers that being a member saves you time and money. You can accomplish a lot in one place. You can position your company, and you can contribute to working groups like the ones that I just mentioned earlier. Next slide. Sponsorships is another way to build your company. Again, more info, you can check out our website, talk to me. I'm not going to tell you more, just the tease. Next slide. Again, if you're interested, I'm a big believer that, being a part of this community is where you're going to find out about what's happening with IoT. Again, we partner with groups like IEEE and SA and MIPI, and we're just really honored to be here today. And I think that's my last slide. And next slide, please. Yes, it is. All right, so thank you. There's my contact info. Let us know. We have the Q&A area, so if you'd like questions, I'm willing and able to answer anything. So thank you, and up next is my friend and colleague, Peter Lefkin.
Thanks, Karen, and thanks to the IEEE-SA for hosting and facilitating this webinar. I think having three organizations like three of ours come together to talk about sensor is indicative of the need, as Karen indicated, to really partner and work together. If you go to the next slide, just a little brief introduction to MIPI Alliance. I see some familiar names and companies who may already be fairly familiar with MIPI, so I'll go quickly through this. We are a global organization, collaborative, and comprising over 280 members. We've been in existence for about a little over 13 years, and so if you can imagine the change in the mobile industry over that time, and we'll talk a little bit about that later as it relates to sensors, but really MIPI has evolved and continues to evolve its specifications to meet the mobile-focused industry, and I'll talk a little bit more about how that's evolving over the years as well. Next slide. What do we do? We define specifications and promote those specifications. That's really our primary reason for being, is developing specifications for mobile interfaces, but they're also becoming over the years more applicable to IoT and auto and wearables. It's amazing where MIPI specifications are being implemented today. We do work with other existing standards bodies, both to coordinate and to enable those organizations to refer to MIPI specifications. We provide the members with access to the specifications as well as the license to those specifications to implement the technologies. And then we also promote the specification implementation of our members in the marketplace, and that's an important activity for us as well. If you go to the next slide. This slide really represents the kind of full sum total of all of the MIPI specifications that have been developed over the years. And it really, if you look at this, it's really the mobile architecture, architecture of a mobile phone. And I won't go through this. We could spend a full webinar just on this slide in particular. But only to say that MIPI specifications, we continue to evolve our roadmap. We continue to take in requirements from new industries that are adopting MIPI specifications, including auto, including IoT, including wearables. So it's kind of interesting to see those requirements come forward and companies joining from those particular industries. And again, there's a lot more information on MIPI's website about this particular diagram. If you go to the next slide. We have a few strategic focus areas in 5G, IoT, obviously talking about that today. Our primary focus remains on mobile and will continue to remain on mobile. But again, we're supporting our members' desire, to evolve the implementation of their specifications in other areas, so moving into auto, moving into wearables as well. If you go to the next slide. MIPI's member ecosystem has really evolved over the years as well. We primarily started with handset manufacturers, device OEMs, and semiconductor companies. Really started the sort of heart of MIPI, which really started with the implementation of a camera in a mobile phone. And as we've evolved over the years, the IP community and VIP community, as well as test labs, test equipment companies, and other consumer electronic companies, and especially those that are also going into IoT, really came together to make up the MIPI ecosystem as well. If you go to the next slide. I won't dwell on this as well, but we have 4 different levels of membership: adopter, contributor, promoter, and founder. The real difference between those 4 is those who are participating in the development of specifications, contributors, promoters, and founders, and those who just receive the specifications once they're adopted, being the adopter members. And if you go to the next slide represents just the contributor, promoter, and board members. We have probably a 3-to-1 level of adopters who aren't pictured here, but you can see the range of both small and large companies who are participating in actively developing the specifications. If you go to the next slide. We have 12 active technical working groups, and the one that we're going to be talking a little bit about, and Ken Foust, who's here on the webinar, chairs the sensor working group for MIPI Alliance. And you can see the various technical working groups. There are other groups that are focused also on IoT, and we see cameras being implemented in IoT devices. We see display. We see our physical interface, in particular DeFi, also being implemented in IoT as well. But our focus on today's call will be certainly sensor. If you go to the next slide. We also partner, as Karen indicated, and MSIG is an important partner of ours, also PCI-SIG, VISA and the Video Electronic Standards Association, USB, Universal Flash Storage Association, and JEDEC. There's also one that's missing here, the Universal Stylus Initiative. We're coordinating and have created a liaison for the touch interface, which is being newly developed within MIPI Alliance, which will leverage I3C right from the start. So that's something that's really interesting and starting to leverage the sensor technology. If you go to the next slide. We had our first developers conference this year, and we're going to continue that into out years, and we're planning for 2017 as well. I've mentioned that because you can find additional information and real current information. The meeting was just in September on MIPI specifications. All those presentations are available, and videos are slowly getting up to the website as well. If you go to the next slide. As Karen also indicated, we're a member-based organization, so we encourage companies who are interested in implementing the specifications to join MIPI Alliance. I won't go through the sort of benefits of that, but if you are interested to join, feel free to reach out to me or contact, go through the website. And if you go to the next slide, which is my last slide. Again, I'd like to thank the IEEE-SA and MSIG for coordinating and participating in the conference. And I look forward to getting into the content of the webinar and hand it over now to Ken Foust.
Thanks, Peter, and thanks everyone for joining. This is a passion project for me, and that's helping the sensor industry mature as we go out in time here, and I couldn't do it certainly without the IEEE, MSIG, and MIPI, who all let me chair or co-chair working groups and initiatives to do that. So as wasn't mentioned, for instance, in MSIG, so the Standards Working Group, it is an effort that I co-chair and helped start, and has been, I think, really was the starting point for a lot of this effort. So I really appreciate the risk that MSIG took in doing that, and look forward to continuing to do that. So I just have a few slides here to talk about the development of MIPI I3C. This is, I think, another a shining example of good things going on in the industry. And it's been about 3 years in the making now, And so as a working group, we were initially chartered in 2013 to solve problems that all of us that have been developing sensors, working with sensors, building products around sensors, we're having to deal with, and it was a proliferation of sensors across mobile terminals, and so this was really at its core. There are many issues that were that we had to deal with, but one of them, one key one, was the requirements for general purpose IOs. So 10 plus sensors on a high-tier mobile device was resulting in 20 or more signals dedicated to the sensor subsystem. So we all got together inside the MIPI Alliance, looked at the incumbent interfaces such as I2C and SPI, and set out to try to put forth a two-wire interface for the future, and I think we've been successful at doing that. So if you can go to the next slide. So what were these goals? Well, let's define this new sensor interface. This was something that wasn't just like, for instance, a simple pet project for one company that everyone had to align to. We developed this in the working group from the ground up, addressing some very specific issues, while also striving to reuse existing industry interfaces and maintain compatibility. As an example, so our focus for developing this interface was low-cost implementation on the sensor side, as always, reduce signal count inside the system, and do that through standardizing in-band interrupts, in-band power-saving commands, and reduce power consumption in the interface in the system itself. And we were able to do that quickly. We moved past it on Karen's slide, but I3C, here, actually, this is a good example. Thank you. If you advance it forward, you'll see that, so we maintain compatibility with legacy I2C devices, but we've been able to reduce the power by approximately an eighth, while if you advance one more time, putting forth an interface which is up to 100 times faster, approximately, than I2C fast mode. So very excited about what we were able to accomplish here over the last 3 years. Lloyd, if you just go to the schedule, which is a few slides before, actually. One more. There we go. So right now we're going through the final reviews of the spec, which should take us through the end of this year, and it should be available to adopters very soon. In parallel, we're developing an application note for system integrators, so to help developers, absolutely, take advantage of all of the great features of I3C. This is something that we put some features in there that is targeting mobile, targeting beyond mobile, and so not all features inside the spec, for those familiar, are required. There is optional capability, and so we're putting an app note together to guide people through adoption of all of those features. So that's all for this topic, Lloyd. Lloyd, are you unmute?
Yeah. So again, okay. Thank you very much, everyone. Thank you so much for Karen, Peter, and Ken for your perspective on things. What I'd like to do at this stage is to remind folks who's on the line that please go ahead and submit questions as you have them using the chat feature. We will collate those questions at the end of the session and read out the ones depending on how much time we have. So with that being said, we'd like to move the discussion interaction with the team here. So I would like to first pose a question to Ken with regards to this very important topic of sensors and growth. So Ken, how are sensors driving IoT growth as you see it today?
Yeah, this is a good question, and what I see is very helpful in driving IoT growth is I think the maturity of sensors now versus, let's say, where many of your typical MEMS-based inertial sensors were in like, let's say 10 years ago or so. So IoT right now has the advantage of leveraging the benefits of many of the sensors that have gone through the mobile and consumer electronics ramp already. So they've gone through that. They've reduced costs and price. The vendors and the technology can meet volume demands. They've maintained performance and reliability. They've continued to innovate and compete. And so I think that the IoT as a mature and stable industry, sensor industry, now feeding it. Also, believe it or not, there's a lot of feature overlap as well, which I think the IoT can leverage. I'll give an example of a 3-axis accelerometer where historically it may simply have a digital interface and provide acceleration outputs, but as the use cases in mobile became more specialized, the sensors themselves competed with or innovated and actually embedded capabilities, like a significant motion sensor or a free fall sensor or a tilt detection algorithm. And believe it or not, these same embedded algorithms, which in, let's say, a wireless sensor network in the Internet of Things, could actually leverage those capabilities as well. So instead of having to run those algorithms on a processor or on some more expensive compute, as much as I would like that at Intel, there are some key features that haven't pushed down to the sensors themselves that are there and waiting for the Internet of Things to leverage them. So there's a maturation and stability in the industry, as well as there are some really neat embedded capabilities in the sensors throughout the industry, which are there to be leveraged by the Internet of Things.
Excellent. Thank you so much for that. Some very interesting and exciting things which are going on there. What I'd like to do is bring in Karen into this discussion as well, with regards to from a slightly different perspective. Certainly when we look at the standards industry, it's, again, exciting. There are many different companies which are, engaged in that side of the house. But Karen, tell me why MEMS or MSIG is involved in the standards work, and, what do you see as the kind of benefit that you bring to the table here?
Great. Thank you. And it started in 2012 when we had our technical conference, which is our MEMS and Sensors Technical Congress. We had it in Pittsburgh, and I invited Len Scheinblatt of Qualcomm to come because he'd been kind of kvetching, to use a Yiddish word, about his frustration with all the different performance specs and all the different spec sheets and such complication of performance standards and different definitions, and it was just inefficient, and it was a wasting of effort and time, and he wanted things simpler. And so I said, all right, dude, I'm giving you the keynote, and so stand up there, here's your soapbox. And so he got everybody excited in in its association, and we formed a working group. It was led by Intel and Qualcomm. Ken mentioned that he's our co-chair. He's been active in this since the beginning in 2012, along with Steve Wally, who's now the Chief Strategy Officer for MEMS and Sensors Industry Group, and he was then at Intel. Len and his colleagues at Qualcomm, and then we got Bosch involved, and InvenSense, and all the Analog Devices, and Kyonix, all the big ST, all the big ones involved, and everybody understood that in order to get to time to market, in order to take advantage of what was then an idea of an IoT, right, we had to come together. So between 2012 and 2014, they created the first performance spec, and these were competitors who had a similar objective, and then we worked with our partners at actually NIST. We have two folks at NIST who really stood out, Herb Bennett and Mike Gayton, who were basically ambassadors to get us to IEEE-SA, and then we worked with them to create the first standard, the IEEE 2700. So it's been a process, it's been collaboration, and it's been, people kind of taking off their company hat and putting on their partnership hat, and creating this issue, bringing it to the forefront. There was a time where I called standards the S word. People didn't want to talk about it. They didn't want to hear about it. 10 years ago, forget it. And I even remember people telling me there will never be any standards in MEMS, and here we are. And I'm really, that's the part that's exciting, and then you're seeing more and more of this development. And I think what's really critical is everybody's realization that it needs to be at the sensor node level, and both Peter and Ken are echoing that. So that's the story of how we got into it.
Right.
Yeah, and Lloyd, if I can just augment Karen there for a second, that's great great background there, Karen. But also, I think not only did MSIG kind of provide this neutral ground for us to do this, but also the velocity that was required for the industry. So we know that there's a lot of standardization routes to take, but we needed something fast. We needed to start aligning quickly, and MSIG allowed us to kind of informally get together and quickly make something that was formal, and that can benefit the Internet of Things as well, and the maker community, and any area that is innovating at the speed of light, but very quickly.
Yeah, and I just building upon Ken and Karen, Lloyd, if I may, I think
there's an open dialogue. Exactly.
Yeah, no, for sure. That Len's presentation also, because MIPI was right at the beginning stages. I was at that meeting, and we were talking about initially developing a precursor, or the next generation of I2C. And as Karen mentioned, there were a lot of people who were not very aligned to it. I don't think that the sensor vendors, they were selling a lot of sensors, and they weren't necessarily feeling the pain. It was all of the mobile device manufacturers, the chip vendors, who were really feeling the pain of, implementing many different sensors into a mobile device. And now, yes, there will be mobile devices with increasing number of sensors, but there's also going to be standalone devices that will certainly have wireless connectivity, but may not have voice and will require sensors. So that early phase, and we leveraged and continue to leverage the MSIG community to ensure that sensor vendors who may not be within MIPI, and there are a lot, and probably a large majority of the market who develop sensors are within MIPI, but for those who aren't, also build awareness, and we're able to feed into the process, and we leverage that information. So again, the collaboration is key in this environment. No one organization, no one company will really dictate the technology, and I think a lot of what we're looking at today is not only evolving mobile, but how do the sensors get integrated and implemented in different ways? And Ken mentioned one that I've been spending a little bit more time with in terms of the maker community, and really quick development and prototyping, and a lot of the companies involved in MSIG and MIPI who typically weren't at that level, the Intels and even the Googles and NXP and others, I see them at maker fairs, and I see them putting together development platforms for the maker community that's really really a lot of interesting applications, a lot of different use cases are coming forward from that environment, which is a really different sort of environment from mobile where, yes, it's leveraging mobile technology, but it's putting it in the hands of developers very quickly.
Yeah, no, absolutely, and I think what's been a common theme throughout here from all three speakers, certainly when we talk about standardization efforts. Yes, as Karen rightly says, when folks begin to initially talk about standard, it's that naughty word, it's that S word, but it's very clear the benefits and the implications that having a standards process around any particular technology brings to the table. And some of the key points which you mentioned, all you mentioned was the collaboration, the consensus, and the openness to actually help drive that and facilitate that process. So thank you very much for the three speakers with regards to that particular aspect. So why don't we just kind of turn more to a more technical realm and go through some of those areas. So, Peter, as you were the last person to speak here, when you look at MIPI is focused on mobile. How do you see MIPI specifications, including I3C, impacting IoT, and why do you feel the specifications are applicable?
Yeah, thanks, Lloyd. One of the real sort of premise that we start any development from is looking at a few different characteristics. One is low power. Two has been high bandwidth, but also low bandwidth, which I'll come back to. And the other is electromagnetic interference, so low EMI. And I mentioned high bandwidth and low bandwidth because typically in mobile we're really focused on the high bandwidth, making sure that we can push as much data within the phone as possible, from a camera or display or elsewhere. And now we're also looking at low speed as well, which is critical for IoT. You may not need the high-speed devices. So MIPI specifications, in particular camera, display, sensor, and touch, which I indicated previously, which is under development, will really all come into play in the IoT in a range of different applications and devices. And we are definitely spending a little bit more time too on the low bandwidth, low speed types of interfaces that we've developed in the past that are now getting even used more frequently in IoT applications. So while we're very focused on mobile, Ken's focus on the sensor interface for I3C has been predominantly on mobile. We know for a fact that it will flow into IoT devices. And the last comment that I'd make is that over the years we've seen a growth, and everybody, I don't know, if I look on my desk now, I see probably 5 or 6 different screens and devices. And we've seen the growth of peripherals happen throughout, leveraging the mobile architecture. We've seen that growth, and that growth will continue for IoT. And the interesting thing about IoT is that it's not just consumer facing. It's industrial. It's medical. It's home. It spreads far beyond where mobile has gone to date. And that's a really interesting opportunity, not just for the Alliance, but for MIPI members. Thanks, Lloyd.
No, great. No, thank you so much, Peter. Karen, let's put you on the spot now with regards to the commercialization aspects of sensors, MEMS and sensors. So what do you think are the 3 biggest challenges to commercialization of MEMS and sensors? And certainly, what kind of discussions do you hear from your members with regards to this? What are the key components?
Yeah, I mean, obviously, everyone talks about price, right, and competition and things like that and getting time to market. But you can't do it. You can't get there if you don't. I think there are 3 really pivotal things. And one of them is obviously standards, and we've been talking about this here. And I think this issue of interoperability in standards is really important. You see the success of something like a Bluetooth, something where but then it's got to be secure, right? And so that's what's really important too. Is you can't just have a standard that's interchangeable and interoperable, but it's got to be secure. So that's why this MIPI I3C is so important. That's why the standards that we're working on are so important, is that security is tantamount, and everybody, and this is something that it has to be at the sensor node level from the beginning. It's got to be hardwired in there. And then lastly, something that I call kind of the holy grail is not only, Peter, do we have many different devices, but we've also got things that need to be charged and need batteries. And so I'm really frustrated with this issue of power management, power creation, energy harvesting. And I really feel like we've been talking about power and energy harvesting and power creation and power management for so long. And we've come closer in terms of, with things like sensor fusion, where you can, things that are, devices are kind of taking turns. I call it taking turns, so that the GPS takes a turn when, maybe a video is being launched on an app or something like that. And so those sensor fusion software and algorithms are being used, but we really need to come further along in energy harvesting, energy creation, power management. And again, it's got to be standardized. Otherwise, it's not going to be adopted. And so, it all comes back to the importance of standardization. And those are the things that I'm hearing from my members at MEMS and Sensors Industry Group. These are the things that they are, obviously they want to be getting new, what's exciting about MEMS and Sensors is that there's always new applications, and it's like new science. So, there's chemical sensors are going to be, we're going to find those in our devices everywhere, and the technology is there. We're going to have really awesome ways of detecting things like skin cancer and things like that. That's really fantastic, and food detection and things like that. But again, if we don't have the standards in place, if we don't have that interoperability, if we don't have the security and the power, it's not going to be, it's not going to affect change. And so I think those are the biggest stumbling blocks to IoT.
Great, and certainly, Ken, from a from a commercialization aspect, when you look at Intel and certainly some of the developments that are taking place there, do you concur with what you're hearing from Karen, or do you see some additional components here that helps to drive this?
Yeah. I mean, I completely concur, and can't stress enough how important it is that for the IoT that sensors be ubiquitous and interoperable. And not only just from sensor to sensor, but how sensors connect, whether wireless or wireless, through wired or wireless. So yeah, I completely agree. I think the sensor industry understands that and is trying to do its part. Certainly, but there's more to be done inside the MSIG working group. In addition to just advancing our standards that we've done, such as the performance parameter definitions, we are looking for more active participation to start new efforts. As an example, so I certainly would consider this an additional call to arms for others to join that discussion with us, because I mean the IoT will offer the same high volume opportunities for new sensor types, whether they're gas sensors, air quality, smart agriculture, that not only can keep incumbent sensor vendors growing, but also bring new startups to the table. And I think MSIG, as an example, provides a good forum for those new initiatives to be heard and have a seat at the table, to help their new sensor technology or niche capability grow and mature, such as others have before it.
Great, thank you very much for that, Ken. I'm sorry, Peter, were you saying something? Okay, no. So certainly at this stage, I'd like to ensure that we give some time to read some of the attendees' questions. David, would you like to pick out any of the questions from our listening audience and share with the team for their feedback?
Yeah, absolutely, Lloyd. Thank you, everybody, for this engaging discussion. I appreciate it. We had a lot of questions come in. I'm going to just go in no particular order here. I see one that I think the panel can go over for the next couple minutes here. The question asks, can someone provide a practical example of what a 100 times increase means in the new IC3 standard? An example of a sensor sending data at a 100 times better rate could mean improved what? Meaning, what is slow now that could be improved upon? So I'll open up the floor to that one.
Sure, yeah, David, I'll definitely take that one. This is Ken Foust. So what it means is a few things. One is the opportunity to take a few fragmented interfaces, let's say I2C and SPI, which exists in the industry, and converge them onto I3C. I2C tends to be low cost but low speed. SPI tends to be fast but costly from a pin count standpoint. I3C has the low pin count of I2C plus in-band interrupt capability, but can run at SPI-like speeds. And the reason some people appreciate those SPI-like speeds, which is, let's say, tens of megahertz versus hundreds of kilohertz where I2C runs, is when systems leverage caching or buffering of sensor data on the sensor themselves. So an accelerometer, for instance, may be caching seconds worth of accelerometer data inside, let's say, a 1 kilobyte FIFO buffer, and when that buffer is full, the host processor needs to get that data quickly, process it, make some kind of inference or decision, and go back to sleep. And so the longer that the host processor is waiting to get that data over the interface bus, the more power the entire system consumes. And so by speeding things up, you reduce system power because one, the host can leverage the buffering capabilities of the sensor itself. So while the sensor is collecting that data, the system can effectively be asleep. And then once the system needs to access that data, it can access it quickly. And then it can go back to sleep. And the way I3C does it is by first running at a faster clock than I2C, certainly at 12.5 megahertz, leveraging push-pull as opposed to open drain, as well as supporting double data rate and ternary symbol transcoding. It allows for more efficient per bit transfer of that data as well compared to I2C or even SPI. So I hope that helps.
Okay, David, do you want to select another question?
Yeah, absolutely. Thanks, Ken. We got about 7 minutes left. Let's try to get to as many of these as we can. How about, what would you say are the biggest hurdles companies face in adopting sensors for the Internet of Things? For example, is it power requirements? Is it size? Is it cost? Is it something else?
All of the above.
I was going to say the exact same thing. Yes. It always is. It always is.
I don't. What's the most important thing? It's like, do you want your right arm or your left arm? I think that's the challenge in this, is that it's all of these things and that's what's even more challenging. It's multidisciplinary and multi-complicated, multi-leveled. I don't know, Ken, if you want to.
I think one of the things that's even a little outside of MIPI scope, but the data that's being generated and the amount of data and the complexity of it that's coming out of the sensors and making sense of it, no pun intended, is really important. And there's going to be services and applications and large industry out there that's coming together to actually make use of the sensor data. I think, a number of us have, wireless, not wireless, but wearables on your wrist. And, so much data is generated from that, but putting it in a usable form, an actionable form, is really important. So I think that's one of the items that's a little bit, beyond the sort of MIPI's focus on the interface, but will be critical for IoT success.
Thanks, everybody. We'll go just down the line here in no particular order. The next question asks, one of the issues that is coming out of our sensors and technology sort of road mapping discussion within my organization is that there's a potential lack of wireless bandwidth to connect the trillions of sensors. Is there a recognition of this in the IEEE? And Lloyd, maybe you can talk a little bit about that. And if so, is there anything happening to address this?
From an IEEE standpoint, I'm not right now when you start looking at that particular aspect of it. It's certainly a very interesting question, and not one I feel I can adequately answer at this particular stage. Certainly, those are key components. But whether or not we're doing anything to actually work on that particular area is, I'm not quite sure at this stage. So I'd certainly pass that over to, any of the other folks on the call right now, but I'm not overly familiar with anything that we're working in that particular area to address that challenge.
Yeah, the only thing, Lloyd, that I would mention is I'm aware of certainly there are 802 groups that are looking both in wired and wireless that are looking at this, and then certainly Bluetooth Low Energy I know is being leveraged and targeted for IoT for sure.
Right.
And this is go ahead, Karen.
No, I was just going to say the other thing that I know I'm hearing from our members, and it's something that we're going to be addressing at our upcoming technical congress, is the whole idea of AI and machine learning, and so I think it's part of that is like you want to have artificial intelligence, you want to make smart decisions, you don't want to have data overload, and so this is a real issue, and I think that question is really important and needs to be addressed. That if we have more and more devices coming online, the pipeline can get bigger, but then it's just going to be noise. So we have to have some machine learning, some AI, some algorithm that affect the decision making and help us. We're all doing this because we want a better planet. We want to be more efficient. We want to have smarter choices. We want better health care. Know that our kid has a concussion after he's been hit in the head. Those are the kind of things that's the kind of stuff we want, is to help the world be a better place, not just have more data points for the sake of data points.
Yeah, and if I can just add to Karen's comment here, and I can't speak specifically to the comms initiatives, but I do agree that it is an issue. And when I spoke about how the sensor industry is helping the IoT and looking at things that were done in mobile, one of the things you can do to alleviate that pressure is to make more decisions and inferences right out at the edge. A lot of the times with a sensor, 95% of the data is useless. It's finding that 5% that matters and making that inference and propagating that result through the network as opposed to streaming that raw data. And so pushing that decision making out onto the edge, onto the devices themselves, onto the sensors, if possible, really does help with that challenge going forward.
Okay, we're running up against the hour. Let's get one more question in. I2C was a Philips spec. Probably a question more for Peter and Ken. Where is the i3 spec available? I'll let you guys handle that one.
Yeah, thanks, David. Then Ken can fill in. And I think there was another question about pulling in other vendors to support I3C as well, and I can address that. I3C is a MIPI specification, and today our MIPI specifications are available only to members. So in order to gain the license to implement I3C within product, you would need to join MIPI Alliance. There actually is a draft that's under review right now by all members so you can get access to that draft today if you were to join. We are looking, and Ken has indicated, and we've put out a good amount of information actually within the slide deck that you'll receive in the last few slides. There's links to technical presentations that occurred at DevCon, I think 3 or 4 presentations. And then there's also an extensive white paper that we commissioned to make sure that there was broad awareness about I3C, recognizing that today it's only available for MIPI members. I would also add that NXP today is the maintainer of the I2C spec, and they are also active participants and supporters and members of MIPI Alliance in developing I3C. And Ken, I don't know if you want to touch on anything else in that regard.
No, I think you covered it well, Peter.
Great, thanks.
Right. Thank you so much, everyone. I think we're right on time now as far as our limit is concerned. So with that being said, I'd certainly like to thank our speakers, Karen, Peter, and Ken, for your insights and your perspectives on this very, very important topic. I'd also like to thank David, who's been providing the logistic and technical support. Again, the information or the presentation will be made available. We'll make that, we'll share that, and those who registered will receive the link to download and certainly view the recording. And with that being said, I'd like to conclude this webinar. Thank you so much for your time, and have a wonderful day.